For centuries we didn't know. Well, now we know. Chemists know what makes water freeze and flow. Chemists know why fireflies can glow. Our chemists know Avogadro, order 10 to 23. The moles never bothered me anyway.
Welcome to Chemists Know. As you can see, since the last episode, we were able to piece co-host Lauren back together. During this episode, we will be discussing chemical reactions and how to write and balance chemical equations. There were 3 parts to this experiment. In part A, 2 compounds were chosen from the following. These 2 compounds were KOH and Na3PO4. To Chelsea and Haley for more.
The 2 compounds were mixed together. KOH was a yellowish solution and Na3PO4 was clear.
There was no precipitate formed, therefore there was no chemical reaction in the test.
In part B, displacement reactions occurred when an element in its purest form displaces a different element from a compound in aqueous solution. Basically, one element bumps the other one out of the way. One can tell when this reaction occurs because there's often a color change, a precipitant formed, or a gas evolved.
10 drops of each solution were placed in a total of 9 different test tubes.
Then a total of 9 pieces of pure metal were added to the test tubes.
Here are the observations collected.
In part C of the overall experiment, there are many different reactions. It was split into 5 sections. In section 1, a reaction between magnesium and hydrochloric acid took place.
Take 0.5 centimeters of a piece of magnesium and place it in the bottom of a clean test tube. Then add 2 milliliters of HCl to the solution to the test tube.
Observe both items separately and record any evidence to prove a chemical reaction.
Here are the observations made along with the balanced and ionic equations. As you can see, a chemical reaction occurred because of the formation of a gas and a temperature change.
In section 2, the reaction was between PbNO32 and Ki.
Add 10 drops of PbNO32 to a test tube. Use a pipette and 2 drops of Ki to the test tube.
Observe and record solutions separately. Also make observations when they are mixed. As shown by the data, a color change occurred and a precipitate was formed. This section was an example of a double replacement reaction.
In section 3 of part C, there was a reaction between hydrochloric acid and sodium hydroxide.
Take 2 milliliters of NaOH and place in the test tube. Add 1 drop of phenolphthalein indicator to the NaOH.
Then measure 3 milliliters of HCl and add 1 drop of the indicator to it. Carefully pour the 1 milliliter of the HCl to the NaOH, then with a pipette add the rest. Record all observations made.
Here are the observations along with the complete and net ionic equations. The reaction was an acid base.
In section 4, FeCl3 and NaOH were reacted. Take 1 milliliter of FeCl3 in a test tube and combine it with 1 milliliter of NaOH.
Here were the recorded observations, along with the balance and net ionic equations of this double replacement reaction.
And finally, section 5 was the reaction of NH4 to CO3.
Filling the end of a microspatula with NH4 to CO3, place in a clean test tube.
Place a red litmus paper on a watch glass. Moisten it with distilled water.
With a test tube, grasp the test tube at a 45-degree angle and heat the bottom.
Record observations of the fumes, and then the test tube walls and openings.
Next, place the test tube to the litmus paper and record what takes place.
The fumes smelled like burnt hair and litmus paper turned blue. Here are the observations along with the equations.
In part A, it was concluded that both products were soluble because when the reactants were combined, a precipitate was not formed. By performing this part of the experiment, one could also draw the conclusion that the anions of group 1A are usually insoluble because of the low KSP values and that they are heavy metals. After doing all the reactions in part B, the chemist could place the elements in decreasing order of reactivity, which is magnesium, zinc, and copper. By determining the order of activity, the chemists were able to determine whether or not aluminum would react to hydrochloric acid, and it was determined it would. Also a reminder, always wear your goggles. In conclusion, this experiment had many different chemical reactions that took place. That's sure, Lauren, they just kept reacting things. The reactions that were observed during the experiment included double replacement, acid-base, single replacement, and combustion. In the experiments, while these reactions were taking place, we were able to see how some compounds were readily dissolved in the solution, but others were insoluble and did not dissolve. Everyone did remember to turn the gas off this time, right? Yes, make sure we do. We do not want to have another mess to clean up. I think all's good. They said they've checked and double-checked. Wait, what's the smell? Oh no, what? I think it's brownies.
You know you can't have food in lab, right?
Oh yeah, I so forgot. That could have ended badly. Thank you for reminding me.
And with that note, thank you for turning in to Chemists Know.
Come back, you hear.
Chemists know what makes water freeze and flow. Chemists know.